Yay! Welcome to our free prep hour. I'm Kat. I teach the GRE. I am also a fiction writer, and I've been doing GRE for 9 years now. So it's been a long time, and I like doing it because I don't actually really like standardized tests, but I really like helping people defeat them, and I love teaching, and I love the people that I get to meet and work with in my job. So I'm here for the human side of it, and I kind of like the problem solving a bit too. They're puzzles. I like puzzles. A lot of the problems we do today will be from this book. This isn't a slightly older edition, but this is a great resource if you want like one GRE book. This is my recommendation. It's divided by subject area and by difficulty. So each chapter starts easy and gets hard. So it's great for targeted practice. The other couple resources that I think are good to have are the official guide, if you don't have it already. That's the one that ETS, the makers of the test, make. And it's not necessarily great for like learning concepts, but it's really great for practice problems, especially for verbal practice problems. And then the other tool that I really love that I'm kind of hyping at the moment, Kaplan makes this tool, this GRE Q Bank question bank, and it is a great resource for like timing and strategy practice in particular, because you can generate like endless time sets, targeting specific formats, specific um, difficulties, specific topics. So I use it a ton in my teaching, and I find that a lot of folks find it's really valuable, especially if and when you get to that place where you have that baseline of the content foundations, and then you are looking more at the sort of strategic decision making side. Um, cool. Uh, The questions on the shorter test are not harder. It is the same difficulty distribution that it has always been. Um, Maybe it feels harder because it's more condensed, but the difficulty has not changed. So the format has changed, but everything about the content, according to ETS, has changed. A couple things to keep in mind. One is, the test changes. So you may take the test, and difficulty is subjective, right? So like I could take the test tomorrow and get a test that feels kind of hard for me, and then I could take it 3 weeks later and it could feel more manageable for me. And that's just, I think, the natural variation of the test and how it lines up with my um, personal strengths and weaknesses. I I um Also, my experience when I took the test last November was it was pretty similar to my experience in the past in terms of question difficulty. I came away feeling like, gosh, there was so much hard geometry. But you know what? There wasn't. There was one hard geometry question that I couldn't do. And because I think of geometry as my strength, I was so mad I couldn't do this geometry question. I really overweighted it in my mind. So I'm going to come back to that idea of like how our sort of subjective memories of things. But it should not, absolutely. There's all kinds of good reasons why you have had that experience. But that isn't necessarily the way it's always going to feel when you take it. And according to TTS, it has not changed. Uh, so that's a good thing to keep in mind too, that there's always a little bit of like luck involved. And that's why I think for many people, who are starting out, budget to take it a couple times. A lot of people take it twice. No one score is ever the final say on what you're capable of achieving on the test. And you may just get better luck the next time. You will get better luck if you take it again. You won't always have bad luck. Um, there is only the shorter tests now, LaSalle. So there is only the 2-hour test. That's it. You cannot take the longer test, and schools are treating both the scoring is the same, right? And I think schools are treating both the longer test and the shorter test equivalently, because that's how ETS has pitched them. Yeah, so it's good news for many people. Um, it may, if you happen to get a test where there's hard problems that are particularly hard for you, it may absolutely produce an experience where you feel like it's an exceptionally hard test. Like I can see difficulty becoming concentrated by the shorter format. But in terms of overall energy, attention, most people are finding that it's a much lighter and more manageable experience. That was my experience as well. So already some great questions. I am very happy to do some probability today. What else should we cover? What other questions or issues would you love to see addressed? And Johnny, let me know if I said your name correctly or not. Welcome. We have a small group today, so I run these as open Q&As, and I think because we have a small group, I can really answer any and all specific questions or target specific areas that are giving you trouble. So please ask for anything you want. And we have remaining 45 minutes where I can hopefully give you good answers and good suggestions and tips. We've had a request for probability. What else should we do? Oh, that's a good one. Real world examples in the assay. I think I'm going to start with that because it's easier to answer than probability. But, ooh, harder number properties. Yeah, I like that. We can do that too. Um, that's a good one. I'm going to answer the essay example first because that's a simpler one. Ideally, I think at least one, two is good. This is one where you can, I sometimes have students like generate a list of 8 to 10 examples that they would want, that they feel comfortable with. And then kind of the prompts are so broad, you can often like shoehorn different examples from that stock list that you have into the essay. So that can be, if you're sort of nervous about thinking of examples, that's a good thing to do. Another good thing to do is get 5 to 10 prompts and brainstorm for 5 minutes for each one. And that can be really helpful as well, just to get that brainstorming step done. Personal experience is also fair game. You can do stuff that's in first person. That is absolutely okay. And in a pinch, you can always invent a personal experience. If you get really stuck, that's always your kind of backup plan, I think. Great. All right. Keep thinking of questions. Send me questions if you have them. I'm going to say something about probability, and I will then do a little lesson on probability, and then we'll look at some harder number properties. And if there's other questions, issues, concerns along the way, let me know. I'll address them. We got time. Here's what I want to say about probability. I think that in general, you really only need to worry about probability if you are scoring a 160 or above in quant. And I say this not because probability isn't worth doing. It's absolutely worth doing. We're going to do it. But because there's not that much. And I know there's not that much probability because I'm not very good at probability, but I am very good at GRE quant. And I know I'm not good at probability because students bring me all these really hard probability questions and I'm like 50-50 on them. But I feel very confident that under any conditions, I can go take this test and get, like at least a 167 in quant because I've done it for many years and I do it every day, right? I've done GRE every day for 9 years. So that's why I can do that. And my probability is fine and I'm good at teaching it, but my probability is not great. And what I sometimes see, and just the trap to be careful of in your prep, is just beware over focusing on the hardest stuff. And if you're at a 165 and you want to get to a 169, absolutely focus on the hardest stuff, right? So there's a caveat, right? If you're in a very high score range, then you want to be focusing on the hard stuff. But until you're getting up there, there's usually easier gains to make from doing things like ironing out small errors, making sure your algebra is super fast, efficient, and accurate. reinforcing and getting faster at your strengths, because you are always, for almost all of us, you're going to skip a couple. And there tends to not be a ton of probability. Not saying it can't happen every now and then, but I have yet to, I've taken it a bunch of times. I've yet to personally have a test with a ton of probability. Um, my colleague took it last fall. He saw two, they were in the harder second quant section. So, yes, focus on probability. But one thing that I found is that there's some correlation between a tendency to want to over focus on super hard stuff and having timing issues. So just something to think about too, in balancing your work. Um, we'll do probability. So I think it's fine if probability is not a natural strength for you to get to a place where you're like, I can comfortably do easy and medium probability. And if I see one that's hard, I'm not going to do it. That's a little bit my take on it for myself. If you like probability and combinatorics and they click with you and it's a good topic for you, then by all means get super good at them and do the hard stuff. And that'll free you up to not have to do some other thing you don't like. But for me, if I recognize the setup, I do it, right? If I'm like, this is a situation in probability or combinatorics that I know, I'll do the problem. If I don't do it, because for me, it is not worth it to be figuring out a new probability and combinatorics scenario for the first time on a timed test. So that's my personal rule for this topic. And I just also want to remind everyone that we are never aiming for perfection in this. Um, cool. I I awesome. Um welcome, Tatiana. We have a small crew tonight, so I'm asking everyone to ask their questions. We're going to do a lesson on probability, but I'm going to answer a couple general. I tend to try to do the general study questions first, and then I get into specifics. So Tatiana, let me know what you wanna get out of tonight's session, and I'll do my best to accommodate that. Yeah. Um, overwhelmed with math in general. I have mixed feelings about Greg Math. I think there's some good stuff in there, but I've also found it isn't always a good fit for everyone. And I've seen some students get really overwhelmed and stressed out working with it. I think it's better for GMAT. Um, so I think just like, use what's useful to you in it, but some of their programming I think can be a little overwhelming and anxiety inducing, like some of their study schedules and timelines. There's so much content, so just use it with a grain of salt. And I do think that their quant is a little bit on the hard side. So getting started, I think in math in particular, getting started, I would set a time limit for each day, right? I would say I'm going to do an hour a day of math each day, and that's it. I'm going to have a really firm boundary about it. But I'm going to be consistent. Consistent repetition in short intervals is so much better, than big chunks of studying on the weekends, which tend to actually not be that effective. We need spaced repetition to learn. So if you're just starting out, and if you haven't been studying, you haven't been in school for a while, say like week one, I'm gonna just do 30 minutes, but I'm gonna do that 30 minutes 6 out of 7 days or 7 out of 7 days. And then you can do 45 and then 60. But it's that consistency that we want to get into. And then set your timer. And then when that timer's done, you're done. And that's it. And you can walk away from the task and put it down. So that I think is one important framing thing starting out. Untimed practice for a month, for at least a month, so that you can build really solid foundations, steadiness, calm, confidence, especially if, like me, you've had bad math. Like I had terrible experiences with math in high school. I still have nightmares about it. So, also we start on time to just allow ourselves to establish a really emotionally, psychically neutral relationship to the task. And then get the mechanics solid before worrying about GRE like problems. So, I would focus just on the easy level problems, whatever's classified as easy, with a specific focus on fractions and percents, or sort of relationship terms, algebra, averages, geometry, number properties, and arithmetic, and get this core stuff really solid and comfortable. Um, Times tables are great. Get a times table app. Like get that sort of little arithmetic comfortable too. Get that refreshed. Um, like Khan Academy is a great free resource for math foundations. Duolingo has a math program. It's pretty basic, but if you're like, yes, I want some pretty basic reinforcement of core math skills, that's a good place to go. Um, and then when you're really confident with the underlying math itself, then start worrying about QC strategy, then start worrying about longer word problems. But I think taking time to just make flashcards, learn the facts, get the mechanics solid, being patient with yourself and doing that is going to make your overall process so much more efficient and so much more successful. And I think that's when I see folks take the time to just slowly and steadily reacquaint themselves with the math, it's a much better overall trajectory. um, do I like Target? I do like Target, and I've talked with them, and I think they're very good and they're very thoughtful. They're much more focused on GMAT, right? They're very much a GMAT company. So I think again, their GRE math is a little GMAT like. It's a little on the hard side. And uh, their vocab. No one has good vocabulary questions. So use ETS for vocabulary questions. Use the official guide and the verbal supplement. I think Target is good for quant. It's good for reading, with this caveat that it skews kind of hard, and it's going to be a little bit more GMAT like in that way, because they took a lot of their GMAT content and imported it um, into GRE land. But I think that it's well made stuff, and they're thoughtful, and they have kind of good pedagogy. So I overall like them. One caution, just because I've been seeing this pop up a lot, um, just watching a lot of videos or other types of passive learning. Um, it's not that this is something you should never do. It's not that it's bad. It's just that in and of itself is not going to get you where you need to be. It's comfortable and it feels like it sort of gives us the feeling of learning, and we do absorb information from it. It's not that there's no learning happening, but it is not enough. And if it starts to substitute for like doing and reviewing problems in a thoughtful way, then it can become like a bit of a panacea that's not necessarily actually advancing our skills. So I think with RegMat, with our GRE Interact, with Target, with any of these that have a lot of those like little short form videos, they're very appealing, but they're a little bit, they're like a use sparingly tool, not a main substance tool. Um, and I say that just because I've been seeing issues around that creeping up. Um, cool. Hi, Chica. Welcome. We're doing open Q&A, so let me know what questions you have that I can answer. What you'd like to get out of today. If you want to tell me anything about where you're at with the GRE, I'd love to know so I can better help you. Um, and I think now I'm gonna go into a little probability. Oh, the other thing in terms of getting overwhelmed with math is just there is a finite amount of math, and you don't need to learn all of it. So like think about you're aiming for 80% of the content that's on it, and you're just going to chip away at it one day at a time, and you'll get there. It takes some time. I think the other place where I'm not always, I think there's sort of this idea out there that like this process should take 3 months. Um, and it just doesn't for a lot of people. Most people maybe I work with, it takes them more than 3 months. Especially because usually people have to balance their prep with their demanding job and their family commitments and their other personal commitments and their the health and all of these things. And so, now is a nice time of year because we have a lot of time before the next round of deadlines for most folks, most programs, most deadlines. And so just allowing yourself to say, maybe this is going to take me 5 months, and that's okay. I'm going to be doing it in these small, steady intervals. And I think that can really help. Yeah. And I'm speaking a little bit to that question. That's a good question. Um, I think, if we're thinking about like we're kind of at the low 150s, I think that there's um a couple things that can help with that. One is to figure out where are their math skills that are not. So, if we're going from sort of like low 150s, and we want to increase, and we're maybe at a plateau, where there's sort of shaky skills, like not even so much the problem solving, but quadratics make me feel uncomfortable. Like I know how to do them, but maybe they feel kind of slow and shaky, or I always forget triangle rules. And just reinforce facts, reinforce, arithmetic drills, basic algebra drills. The that can be a huge source of boost, especially because those are things that I think you can do when you're a little more tired. Is that kind of drill work with math. So getting an arithmetic game that you like to play online or an app, doing that is huge. Just doing easy, a volume of sort of easy problems. The easy problems tend to be more just about the executing the math mechanics than layered problem solving. I think that's good to do. And then the other thing is to really eliminate small errors. I call them small errors because they're never careless. We all care enormously about doing well on this. But a really low hanging fruit for boosting score in weeks is to eliminate small errors. So just, repeat problems you make small errors on, and really work on your written work. Being super neat, super careful, um, uh, lots of extra notation if needed. I think that those are two sort of lower intensity things that can be really helpful. Um, and so thinking about one exercise, if you have the 5 pound book, is go through the 5 pound book, do the first 8 problems in each quant chapter. Those should feel smooth and comfortable. For any chapters where they don't feel smooth and comfortable, go and do a bunch more kind of easy problems or drills, or you can get like high school math worksheets to do on that topic. But that's a good way to diagnose where there may be some content issues that I can iron out through like flashcards and drill work. And then I think that can get you up into the mid 150s, up into the like 155 to 157 range. Then it starts to be, we have to do more sort of problem solving and strategic work. The other easy way to boost your score is just do fewer problems. Let yourself off the hook more on the test, skip more, take the time to then be more accurate on the ones that you can do. So that's also a strategic thing that I see. It jumps people's scores up, 3, 4, 5 points sometimes, just by saying, oh, I'm being really stubborn about doing all the questions. And so I don't have enough time to act, I'm being stressed by the things that aren't good fits for me. And I don't have enough time to execute well in the things that I can do well. And let me say, like, I'm going to be more aggressive about not committing to things that are not good matches for my current skills, and invest that time. And I'm going to only do 7 out of 12 questions in that first quant section, but I'm going to have extra time to really get those 7 right. That's another, it takes practice, because that letting go and knowing what to let go of is not easy, but that can be a great technique for kind of quicker the score boost. All right, these are wonderful questions. Thank you. Keep asking if you have further questions, if you have follow-up questions. I'm going to transition us into a small lesson on probability. And I am going to start with what I think is, this sort of core of probability. So if you're just starting out and you're like, oh no, probability, don't stress. We're going to start with stuff that's straightforward. And then if you can sort of just say, oh, okay, now at this level that it's getting more complicated, I'm not gonna stress anymore. but let's start with the basics. Yeah, if you get 7 out of 12 on the first quant section, you'll probably place into like the moderate second quant section, and then you do like 10 out of 15 on that. You do well on that. You can get to the mid 150s. It is not a test where we're aiming to be perfect, right? And I actually think that one of the big pitfalls is that we aiming for 100%, we don't do ourselves favors. And I see people underperforming their skill levels because they're trying to do every single problem well. And for most of us, we don't need to get the score that we want. And so that's a huge adjustment that I work on with students all the time. I'm like 80% of 80% is good. And that comes to learning the content too. Like, right, you do not have to thoroughly master every content area to get a great score. I'm not going to say like exact, I can't say because we don't know because ETS doesn't expose like this is exactly how many you can miss to get this score. But these are my rough senses based on observing a lot of student practice tests, like the ETS practice tests, and collecting data from students who've taken the official test and all of that. So that's my sense. Let's do a little probability. So I want to bring us back to like the core of probability, which is we just need to think about what we need, what we want over the total number of options. And that's it. That's the essence of probability. And so, one thing with any subject, if you become uncertain of it, come back to the core, the number of items we want over the total number of items. And that's it. Probabilities are always between 0, which is 0% chance of something happening, and 1, which is 100% chance of something happening. We can't have more than 100% chance. So this is also a good safety net for probability, right? If your answer is not a fraction, decimal, or percent between 0 and 1 or 0 and 100 in the case of percent, something went a little haywire. And that's fine. We can figure it out. Fractions are typically how we see probability expressed. Occasionally, we will see decimals or percents. But a lot of probability work is with fractions. And just a little warning is don't forget your fraction mechanics when you enter probability. There's sometimes weird thing that happens is we get into probability and suddenly everyone's core fraction mechanics go out the window. Let's just try a couple. Here are 2 for you to try. You can send me a chat when you have your answers. And you can ask me a question if you're looking at these and you weren't sure about something. I'll give everyone a couple minutes to work on them, and then we'll discuss, and then we'll layer on some kind of additional trickiness with probability. All right, just for the sake of time, let's pause there. And if I haven't already heard from you, let me know where you're at. If you have one answer but not both, if you're like, this is a no for me today, which is also totally acceptable. We have folks in kind of very different parts of their prep processes here today. Um, Send me a chat. Let me know how you're doing. I haven't heard from you. Cool. Um, Let me know if I haven't heard from you, but otherwise, let's talk about them. Um, Probability. As soon as I see probability, I think, what are the number of things I want? If I want to pick red, that's 5. And then what's the total number of things? Well, that's 12 blue plus 5 red plus 7 equals 24. And so it's 5 out of 24. At random is the kind of language, and you'll see this in various topics, language that's just there to make the problem doable and fair. We're not intentionally making a choice, in which case it would be very, it would be a kind of impossible problem. It wouldn't be a probability. So at random, or, fair, like a fair coin or a fair die, that you'll see language like that in the problem. For the second one, we're working with the same jar and we want marble that is not yellow. So not yellow would be blue in terms of what we want. Blue or red. And so that would give us 12 plus 5, which equals 17. And then we still have 24 total. So 17 over 24. Notice that when I'm using here the word or, I am adding, right? In probability, or gives me more options. Could go to blue or red. I'm increasing the pool of things I want. So when I see the word or, I'm thinking I'm going to end up with a bigger fraction. And to get a bigger fraction, I add. It's a little counterintuitive, right? I think sometimes we think of or as differently, but in probability, or more options, bigger fractions we add. Now, the other way that we could think about this problem, which we don't have to for this particular one, is yellow, not yellow, plus yellow equals all options. And we know that all options in probability adds to 1. So 1 minus the probability of yellow equals the probability of not yellow. So I'd say, okay, there's 24 over 24 marbles minus 7 over 24 yellow. That's going to give me the same thing, 17 out of 20. So 2 different options. I could think of not yellow as blue or red, or I could think of not yellow as 1 minus yellow. This is going to come back, the or is going to come back in now when we now talk about multiple decisions, choosing multiple things. This is more important for hard probabilities. So this is unlike GMAT, but in GRE, the 1 minus don't want solution is usually just for really hard problems. And depending on how time goes, we may see one of those or more of those today. So let's talk about what happens when we have multiple selections. So we've done one choice, and there are some problems. There's an official guide problem, a graph problem that is a single choice probability question. But a lot of probability questions involve multiple choices. So we're going to pick 2 or more items, or toss a coin 2 or more times, or roll a die 2 or more times, we're going to have multiple decisions. And I want to lay out a process for how you might approach these types of probability. Step 1, I draw the number of options. I draw the number of decisions or actions. So I'll say, cool, if there's 2 flips of a coin, there's 2 flips of a coin. Number 2, I think about each of those decisions on its own. And then step 3, I combine. Now, if I'm saying, I'm going to pick this or that, we just saw that's a situation where I'm going to add. But in a lot of situations, we're thinking this and then that. And in this situation, we're going to multiply. Now, quick question, sort of common sense. Which feels more likely, flipping a coin and getting heads? Or, so we'll say that's option A. Or option B, flipping a coin twice and getting heads both times. Everyone chat me, A or B, which of these feels more likely to you? Like just based on sort of real world intuition, no calculation required. Flipping a coin and getting heads, or flipping a coin twice and getting heads twice. Yeah. Good. We're like pretty quickly and confidently going with A, which is correct. So we can trust in word problems in general and in probability, we can trust our sort of common sense knowledge of the world to give us a little bit of a boost, to give us some guide rails for how we process, right? The GRE, it has a lot of tricks and weirdnesses in it, but it still happens in the same physical reality that we're living in. It doesn't defy the laws of physics. So when you are doing probability, think about, okay, am I in this less likely situation, right? So when I have the word and or the word both, when I need more outcomes to pile up together and to all happen, that's where I'm in the land of it being less likely. And so I want a smaller fraction. And when I multiply fractions, they get smaller. So if you're giving yourself more options, like I could go this way or that way or that way, I'm adding things to the pool, you're going to add those fractions to increase your odds. But if you want this and then that, or this and that, or both of these, that's the situation where, yeah, it feels like that's going to be rarer to occur. And so that's where we're going to multiply. And this how do I multiply, I think is, there's like 3 tricks in probability. And this is the biggest and sometimes I think the thorniest trick for people. So I'm going to demonstrate this in a sort of simple problem. And then we're gonna try it ourselves. So let me demonstrate this process here. So I have a fair coin is flipped 3 times. Cool. So I have 3 actions. So I'm going to start by drawing my 3 spaces. And I want them all to be heads. So I'm going to label. By the way, I use the same sort of foundations for combinatorics too, which is like the cousin of probability. I want heads. And I want all of these to be heads, right? So this is one of those like, oh yeah, this and then that and then that. That feels weird, feels less likely to me. So I'm going to multiply. I fill in, heads is 1 out of 2. Heads is 1 out of 2. Heads is 1 out of 2. And then fraction mechanics. I multiply all my numerators together, I get 1. I multiply all my denominators together, I get 8. And since this is a comparison question, 1/8 is less than 1/6. I'm going to pick quantity B. I'm identifying the bigger quantity. All right. Now I want to have you guys try it. We're going to do a similar type of thing. But we're going to look at a dice. We're going to look at a die or dice. We want to have two rolls, and we want to roll prime numbers on both rolls. 2, 3, and 5 are the prime numbers here. One is sneaky. It's not prime. Since this isn't a number properties question, I'll give you that info. Try this question. Chat me when you get an answer. If you finished that one, you're still working on that one, keep working on that one. Ask me questions. If you finish that one, try this other one. All right, let's talk about it. First one, I start the same way. What is my chance of rolling two prime numbers? So I have two rolls, and I'm going to label them prime and prime. And cool, I want two, I want both, I want this and that, so this is going to be a multiply. There's 3 prime numbers out of 6 numbers total. And then I always reduce fractions before I multiply them, whether it's probability or a fraction problem. So I'll reduce them to 1/2. And I get 1/4. This second one is weird. Yeah, absolutely can do that again. Yep. So here, let me see if I can do it again differently, and let's see if that's helpful. here, I'm going to start by saying, all right, what are the odds of just rolling one prime number, right? Maybe I'll start with that and I'll say, okay, what I want are my primes, and there's 3 of them. And my total number of options are 6. So if I were just going to roll one prime number, it's going to be 3 out of 6, which I can reduce to 1/2. Now, right away, maybe I just think about it with that like common sense thinking. I'm like, well, 2 primes has to be less, right? Because it'll be weirder to get 2 primes than to just get one. And so if I know that it's less likely to get both, I know I'm going to multiply those fractions together. Now, another thing that I think is important to say is always assume you get what you want. So on that first roll, I'm going to have a 1 out of 2 chance of rolling a prime number. And then I'm going to multiply that by the chance that I have on the second roll. And rolling a die doesn't change it, so I'm going to have that same probability on the second roll, and I'm going to get 1 out of 4. The logic behind this, in case it's helpful, I'll show you. I would not use the method I'm about to show for solving a problem. Is like I can either get a prime or a not prime, right? So on my first roll, I get a prime. And then on my second roll, I have the same option, right? I could get a prime or a not prime. Or a not prime. So what I see is it's like a branching tree kind of logic. There's 4 different pathways I could travel. But only one of those is prime prime, which is what I want. So our multiplying is really just shorthand for this kind of branching tree. All right. So the second one, right? The second one is weirder. Exactly. We may also see language like at least, at most. This is where life gets a little bit more complicated. This is the layer that makes probability hard, or starts to make probability particularly hard. I think probability is hard at every stage. It's very not intuitive for a lot of us, including me. Human beings are really bad at weighing the likelihoods of things happening. That's why we tend to make not great choices. Exactly one prime number. Cool. So I'm going to just, again, I start always probability by thinking about what's actually happening. So if I want exactly one prime number, well, I could roll a prime on my first roll and a not prime on my second roll, and that gives me exactly 1. Is this the only way that I could get that result? Only way I could get exactly 1 prime to roll a prime and then not prime. Yeah, I could also have this happen, or I could travel a different path, but it's still going to give me what I want. And so this is the next level of complexity with probability, is where there are multiple pathways I could travel down. I could go through door 1, prime, not prime, or I could go through door 2, not prime, prime. And those are both going to give me my result. So to start, and again, it's an and, this and that. So I'm going to multiply. And again, I start the same way. 1/2 of prime, 1/2 of not prime equals 1/4. So that's how likely I am to roll a prime and then a not prime, but that's not my only option. So then I go to my next option and I calculate that, and I get 1/4. And then here I say, okay, it's or, right? I could get this or that. So I'm going to add these together. This is like my blue or red, coming back to that idea. So maybe I roll a prime first and then a not prime, or maybe I roll a not prime and then a prime. Those are both exactly 1. So my total odds, my ultimate solution is going to be 1/4 plus 1/4, which gives me 1. And that's like the tricky the sort of trickiest layer of probability often is that there's more than one road we can travel down to get what we want. And so we have two and situations, and then they're joined as an or. This is why always with probability, I start by drawing out the situation on my paper. And if I can't do that, then I know it's not a good problem for me to do. At least admits exactly, these are the language cues too that tell us, oh, I bet it's one of those where there's like multiple ways to fulfill the thing that I'm being asked for. Questions, because this is sort of in some ways the trickiest layer. The one, we're almost at time, but the one like thing that also, the one other component we have to account for in probability is this. What is different about this problem from what we've seen so far? Don't tell it, but do tell me what's different. Yeah, the amounts change. So with coins, with dice, we don't have to worry because our actions don't change the object. But for most other probability, we do have to answer the question of are our actions changing the number of things we want and or the total? And in this case, if we're eating it, yes. They might also say replacement or no replacement, or they might use the word simultaneously, which is no replacement. I know it doesn't necessarily make sense, but that's the way Cherry thinks of it. So for this, I'd say, all right, I'm going to start with 5 red ones over 10 total. But then after I eat that red one, right, I assume I get what I want. So I get a red one and I eat a red one. Now I only have 4 red ones left. And then the total also changes. That's the little trick here. I also only have 9 total left. And so that's my last twist is do I replace or not? And that's it. These are all the building blocks of probability, right? There's not more like important facts that I can tell you about probability. So the things we consider in probability are how many, what do I want? What is the total? How many decisions am I making? How many objects am I choosing? How many times am I rolling the dice? Do I replace or not between decisions? Is there more than one path to my desired outcome? And then just, can I draw out the setup? If not, skip. So this is all we need in terms of foundational knowledge of probability, but absolutely it can get weirder and harder and trickier in all these different scenarios. And this is generally true of quant. First, master the facts. Then see a lot of different problems on that topic and learn the common patterns, right? Okay, if they're asking about odds and evens, these are the 5 to 7 ways they tend to ask about odds and evens. These are the sort of 4 or 5 most common tricks in probability. Not to say that those are all the common patterns or tricks in any topic, but then if you see a pattern, a type of problem you've never seen before, you don't sort of understand or recognize where to begin, that's a great one to not do. And we're allowed and encouraged and will probably benefit from not doing all of the problems. All right.